So in channel, far field due to an far field due to an alternating current ആണ്. An alternating current. Far field due to an alternating current. അപ്പൊ ഇതെന്താ? Alternating current element ആണ്. Alternating current element. Okay. So alternating current element ആരാ? Alternating current element എന്ന് പറഞ്ഞാൽ ഓസിലേറ്റിംഗ് ഡൈപോൾ ആണ്. സോ ഡൈപോൾ എന്ന് വെച്ചാൽ എന്താ? ഒരു ഡൈപോൾ അല്ലെങ്കിൽ ഹെർട്സിയൻ ഡൈപോൾ. സോ ഹെർട്സിയൻ ഡൈപോൾ is a dipole. Hertzian dipole is an antenna whose separation, okay, means the separation between the conductors, okay, the separation between the conductors of the antenna is what? Is half of the wavelength. The separation between the conductors of the antenna. So I said earlier that the antenna is basically what? Basically two conductors separated by some distance. So when we apply some alternating current here, we get a varying potential like this. So here we get positive potential, here we get negative sign. So it is varying. So alternating current in the sense, it in the next half cycle it will become negative and this will become positive. So what is the thing in Hertzian dipole? In Hertzian dipole, it is nothing but the separation between the conductors is half of the wavelength. The separation between the conductors is half of the wavelength. So it is Hertzian dipole, or simply a dipole or an oscillating dipole. Why it is termed as oscillating dipole? Because the alternating current induces an oscillating potential here. Okay. So this is meant by a Hertzian dipole. So we are investigating what? We are investigating the far field due to an alternating current element, or what? Oscillating dipole, which means Hertzian dipole. So look at this. This is what? This is an elementary conductor, filamentary conductor. Okay. Filamentary current carrying conductor. This is a filamentary. Filamentary in the sense it is very small. So it is a filamentary current carrying conductor. Next, what is the thing? Here we consider, this is what? This is the far field region. Okay, I have explained earlier what was far field and what was near field. Far field was what? The area beyond what? Beyond R is equal to 0.63 L. Okay. So there was some R termed here. So that beyond that R, what we get? This far field we get. Okay. So so this filamentary current carrying conductor is placed at the origin. Okay, is placed at the origin. So what? A magnetic field is induced here. A magnetic field is induced, and we are considering a point in the far field region. We are considering a point in the far field region, the distance from the origin of which is what? Small r. The distance from the origin of which is small r. So the vector ER, the electric field vector ER in the direction of ER is taken like this. Next, E theta. So this is what? This is spherical coordinate system. Because of what? Because as we know, the field induced by this current carrying conductor. Okay. The field induced by this current carrying conductor is what? Is in a spherical surface. Is in a spherical surface. So what? So this theta r and theta is what? In the spherical coordinate system. R and theta is in the spherical coordinate system. So approximately at the middle of this means this, what is this? H5. Okay, this is H5. So ER and E theta are perpendicular to each other. H5 is perpendicular to that. So ER and E theta are the components of what? H5, the electric field components of the magnetic field in the phi direction. Okay. So what is this? This is theta. If this is theta, then what would be this distance? That distance is r cos theta. Then what would be this distance? This distance will be opposite. So what? R sin theta. Then this angle is taken as phi. So what? R theta phi. What is that? The spherical coordinate system. Okay. So what is this? Ideals cos omega t. In which direction is this current carrying conductor? The current carrying conductor is in the direction of cos theta. So it is an elementary. I told earlier, it is an elementary or filamentary current carrying conductor. So filamentary in the sense it is very small and thin. So we can take it as ideal cos theta. We can take it as ideal cos theta because of cos theta, and theta we take it as omega t. Theta is replaced by omega t. So ideal cos omega t is nothing but what? This filamentary current carrying conductor. Okay. So as we know, we need to mention one more point, which means this is the current carrying conductor. So this magnetic field, I said earlier, this magnetic field is like this. So how we can mark this magnetic field? This is into the plane. Okay. Into the plane because of what? Right hand thumb rule. Right hand thumb rule, in the case we hold this current carrying conductor, then it is in the upward direction. So the magnetic field is what? Into the plane. So the magnetic field is into the plane. Next what? The electric field. The electric field is what? Outside the plane, because of what? ER and E theta are outside the plane. Okay. This is what? This is the configuration of what? A Hertzian dipole. A Hertzian dipole, or nothing but a current carrying conductor. Why we are considering a Hertzian dipole in this case? Because our antenna can be considered as an aggregation of many elements. Our antenna can be considered as an aggregation of many such small elements or filamentary current carrying conductors. Okay. So that is why we are considering this filamentary current carrying conductor for what assumption in this case. So what is, so you understood the Hertzian dipole. Next, it is saying that a time varying current I is flowing in a very short and very thin wire of length dl in the said direction, where dl tends to 0. This dl is what? dl tends to 0 means it is very short or very thin in dimension. So this current is given by IDL cos omega t. So this current is given by what? IDL cos omega t. Because of what? Cos theta. This is in the direction. This current carrying element is in the direction of cos theta. Cos omega t. Theta replaced by omega t. So in the said direction, it is the current carrying conductor is placed. So since the current is in the said direction, the current density J will only have a component. So what? Since the current is in the said direction, the current current density will only have what? Said component. So we can write current density as what? Current density as J is equal to Jz Az. What is Az? Az is nothing but the unit vector in the z direction. Okay. So the vector magnetic potential A will also have only a z component. So we need to find out the vector magnetic potential in this case. So vector magnetic potential also will have what? Only the z component. So what will we get? Az. Az in the sense unit vector in the normal in the z plane. So unit normal vector in the z plane. So Az is what? The magnitude. So magnitude into unit vector gives what? This vector magnetic potential. So vector magnetic potential is nothing but Az into Az. Okay. We consider the spherical coordinate system rather than cylindrical coordinate system. So as we know, cylindrical coordinate system, okay, cylindrical coordinate system was suitable in this case. Okay, cylindrical coordinate system was also suitable in this case, but what we are considering the spherical coordinate system. because of easiness. Okay. Because of easiness to consider, we are considering the spherical coordinate system for assumptions. Okay, for calculations. So what? We need to convert what? The transform the cylindrical coordinate system to what? The spherical coordinate system. So cylindrical coordinate system were also suitable for what? The assumptions of this current carrying conductor or Hertzian dipole. But we are taking spherical coordinate system. So we need to transform what? The cylindrical coordinates to. So it is basically in the cylindrical coordinate. We need to transform the cylindrical coordinates to what? To spherical coordinate system. So it is basically in the cylindrical coordinate system. So AR is equal to what? AR is equal to what? AZ cos theta. Okay. AR is equal to AZ cos theta. A theta is equal to what? Minus AZ sin theta, and A phi equal to what? 0. Okay. So AR is equal to what? AZ cos theta in the direction of R. So cos theta. A theta perpendicular to what? AR. So sin theta. A phi what? 0. So because of what? The component is 0 in the phi direction. Okay. So what? AZ. This magnetic vector magnetic potential AZ is given by what? Vector magnetic potential component AZ is given by AZ equal to mu by 4 pi IDL cos omega t minus r by v divided by r. Okay. This equation we have studied earlier in the case of retarded potential. So we have taken a class before it regarding retarded potential. So there we have studied this equation. So what? AZ is equal to mu by 4 pi I dl cos omega into t minus r by v by r. So this is nothing but the vector magnetic potential in the z direction. So what? So we need to substitute here this equation AR, A theta and A phi. So what is AR? Mu by 4 pi IDL cos omega t minus r by v by r cos theta. Okay. AZ into cos theta. AZ is nothing but this equation. So into cos theta gives what? AR. Next is A theta. A theta is what? Minus mu by 4 pi. Okay. Minus AZ sin theta. So minus mu by 4 pi IDL cos omega into t minus r by v by r cos theta. What? Minus AZ sin theta. Okay, not cos theta. So minus v by r theta. So AR is nothing but AZ cos theta. A theta is nothing but minus AZ sin theta. A phi is nothing but 0. So AR and A theta we substituted AZ in this equation. Okay. So what is B? What is B? We know that B is equal to del cross A. Okay. B is equal to del cross A. When we do this del cross A in the R direction, we get what? 0. So del cross A is nothing but mu H. So B is equal to del cross A is nothing but mu into H. So del cross A in the R direction, we get a 0. So del cross, what is del cross? Dou by dou, means del cross A in the R direction, we get theta A phi likewise. Okay. Del cross A, we do the differential. Del means what? Del means the differential process. So you differentiate with respect to in the R direction, you get what? You get 0. Okay. So we can say what? Mu HR equal to 0. Likewise, you get mu H theta is equal to 0. So we only get what? Mu H phi. So only we get the factor H phi. Okay. All the other terms in the magnetic vector potential is 0. We only get mu H phi the component. So that's why we denoted the term only H phi here, because we only get H phi as the component remaining. All other things are 0. So what? Del cross A into R is equal, del cross A in the R direction is equal to mu into HR is nothing but 0. You do the process by del is nothing but dou by dou theta. Here R is taken means dou by dou theta into A phi minus dou by dou phi into A theta. Likewise, you interchange the components. Likewise, next theta means what? Dou by dou R into H into A phi minus dou by dou phi into A R. Likewise, the other two, if theta is present, the other two, which means R and phi. If phi is present, the other two, which means theta and R. Likewise, you differentiate. Okay, likewise, you differentiate and you will get the equation. So you will get what? You will get 0 as the answer. You will get both equations as 0. So mu HR and mu H theta equal to 0. Only mu H phi will be the remaining factor. Mu H phi will be the remaining factor. So what? When a current I flows in a very short length of thin wire, so this current I is flowing through what? Very short length of thin wire. The current is constant along the length. So this current, we can assume that it is constant along this length because the length is so small. So any physical circuit or antenna carrying current may be considered to consist a large number of such elements joined into it. So I said earlier that an antenna may be considered as a large number of such conductors joined end to end. Okay. So what? So AR equal to AZ cos theta, A theta equal to minus AZ sin theta, A phi equal to 0. All this we got. Next we have to find out what? H phi. Okay. So H phi is equal to is H phi? H phi is nothing but 1 by mu r. So this mu we taken denominator 1 by mu r. So the equation was what? The equation was del cross A phi equal to mu H phi equal to dou by dou r A theta minus dou by dou theta A r. This is nothing but what? The del cross A equation or mu H phi equation. So 1 by mu r. This mu we taken downward. So what is dou by dou r? Dou by dou r A theta. A theta is nothing but minus AZ sin theta. Minus AZ sin theta. Minus what? Minus dou by dou theta. What is AR? AR AZ cos theta. Okay. This is the equation. So, dou by dou r minus AZ sin theta by minus dou by dou z minus dou by dou theta AZ sin theta. This is the equation. So what? So, equal to what? Equal to 1 by mu r dou by dou r minus r mu by 4 pi. What is this AZ? What is AZ? We have written earlier AZ. Ideal cos omega t. AZ is nothing but ideal cos omega t minus r by v. So, this is the equation of what? H phi 1 by mu r dou by dou r minus AZ sin theta minus dou by dou theta AZ cos theta. So, what are we taking? We are taking as AZ as ideal cos omega into t minus r by v is the equation. So we substitute here and sin theta. So what? So just differentiate this equation with respect to partially differentiate. Partial differentiation you already know. So just partial differentiation and you will get what equation? You will get final equation as what? Equal to ideal sin theta by 4 pi minus omega sin omega t minus r by v by rv plus what? Cos omega t minus r by v by r. So this is sin theta and all, you differentiate, you will get cos theta. And here cos theta, you differentiate, you will get sin theta. Likewise, you differentiate and at last you will get this equation. Okay. So differentiation, you please need to show it in the answer itself. You need to differentiate and show in the answer. So So once more I will tell. So what was that? The dipole, Hertzian dipole. Okay. Hertzian dipole was nothing but a small current carrying conductor. So the right hand thumb rule, a current carrying conductor in the upward direction. So the field is what? Into the plane. Okay, into the plane. So Hertzian dipole in the sense, the separation between the two conductors of the antenna is nothing but half of the wavelength. Is comparable to half of the wavelength. Next is what? A time varying current is flowing through this, a time varying current. Okay, that is why a magnetic field is induced here. So in the Z direction, the current is flowing in the Z direction, and DL, the length of this conductor is DL, and DL tends to 0. So this conductor is what? Ideal cos omega t. Ideal cos omega t in the sense, DL is the length of the conductor and I is the current flowing through it. I cos omega t in the Z direction or in the upward direction, in the cos direction. This is cos, no? This is theta. So this is cos theta. So theta replaced by omega t. So what? So J equal to Jz Az. So the current density J is equal to Jz Az because only the Z component exists. Next, in the case of vector magnetic potential also, the Z component exists. So A equal to Az, where Az is the unit vector. So what? So as we know, here we are taking spherical coordinate system. But for more approximations, we are taking cylindrical coordinate system transformation here. So basically we are representing it in cylindrical coordinate system, and then we are transforming it into spherical coordinate system. So what? The equations would be what? AR, the spherical coordinate system is equal to what? Az cos theta, A theta equal to Az sin theta, and A phi equal to 0. AR, A theta, and A phi we got in the R direction, in the theta direction, and in the phi direction, in terms of theta and Z directions. So what? So we are del square A equal to del square Az equal to minus mu Jz. So Az equation you know already. Az equal to mu by 4 pi ideal cos omega into T minus R by V by R. So we substitute AR and Az here also Az. Okay. Now we do what? We do the differentiation process. Okay. Now we do the differentiation process. What is the differentiation process? If this is differentiation process is nothing but dou by dou del cross AR. Del cross AR is equal to what? R. If R is present, the other two variables you consider and differentiate with respect to that. The component is what? If R is there, one component you take phi and you differentiate with respect to what? Theta. Next you consider minus sign and one component, the other component what? Theta, and you differentiate with respect to phi. Likewise, you differentiate all the things. You will get del cross AR and del cross A. Theta is nothing but 0, or mu HR or mu H theta is nothing but 0. So the remaining thing is what? Mu H phi. So only mu h phi remains. That is why we are indicating only h phi here, the component h phi here. H phi and E theta and ER are indicating only these components here. So what? The antenna is what? An end-to-end connection of what? Such an end-to-end connection of such current carrying conductors. Okay. So only the H phi component remains. Only the H phi component remains. Now you consider the equation of H phi. H phi is nothing but, so what was that? Del cross A. H phi is what? Del cross A phi. So what? Del cross A phi means dou by dou R A del cross A phi. So dou by dou R A theta minus dou by dou theta A R. Dou by dou R A theta minus dou by dou theta A R. So that I think you understood this. If this is phi, this component will be theta and R. Likewise, the differential will be R and theta. The differential with respect to the alternative components. So you substitute what? A theta. What is A theta? Ideal cos omega into T minus R by V by R. So A theta equal to A z sin theta. So A z is nothing but ideal cos omega T minus R by V by R. So A theta is what? Into sin theta. So you substitute there, you differentiating the sin term changes to cos and cos term changes to sin, and this and the sign, negative sign and positive sign you take into consideration, and at last you will get the final answer. So this is the magnetic field, or what? Far field due to an alternating current element. Okay? Far field due to an alternating current element, or what? An oscillating dipole. Dipole in the sense Hertzian dipole, which means two poles. The dipole means two poles. One pole. So one pole is positive means other pole is what? Negative. That's the thing. Okay. So this is the far field. So we are considering field. So we already learned what? Retarded potential. We already learned retarded potential. Next, we are learning what? The electric field components that I will take in the next class. Okay, you please say the attendance. Roll number 1. 1. 2.
Present, Miss.
3. Okay. 4. 4. Absent. 5. 6.
Present, Miss.
7. 7. 8. 9. 10. 11. 12.
Miss. Hello. Miss 7 plus 7 present ആണ്. ഞാൻ അത് 6 ലാണ് present ആണ്.
Okay, okay,
Okay,
7
miss.
present. Okay. 11.
Miss
Okay.
11 present.
Okay. 12. 12. 13. 14. 15. 16. 7. Okay. 17. 18. 19. 20. Okay. So the absent is only 4. 4 means Archita. Archita മാത്രമേ absent ഉള്ളൂ. Archita മാത്രമേ absent ഉള്ളൂ. Okay. Archita absent. Okay. Okay. Okay, ശരി.